So an important concept is that of single and multi-body parts within Design Modeler. So by default, Design Modeler places each body into one part by itself. So if we have single body parts, we have individual parts that are meshed separately. So the example here on the top right is of two parts and two bodies. So we have two solids, which both have the same name here, solid and solid, one being unfrozen and the lower one being frozen. Each of them are in separate parts, and what this means is that neither of these solids see each other because they're in separate parts. Now if we were to place each of these bodies into a single part, then these would then be able to see each other, and this means that we can then perform a Boolean in printing or share topology, so that they can then begin to share the lower topology with each other, so that effectively then we're allowed to form a conformal interface. Without the sharing of topology and in separate parts, we would automatically create a non-conformal mesh at the interface. It's important to note that even though two bodies may be in the same part, in order to create a conformal mesh at the interface, we must have surfaces that are coincident with each other or are within the tolerance in order for shared topology to be successful, so they can each share an intermediate lower topology. But we'll see some examples of the effects of sharing meshes at the interface as a result of a separate part or as a multi-body part. And the multi-body parts can be generated in different ways. We can simply use select and control select or shift select to select all of these bodies, then simply right click and select form new part, and that will create this small icon that's shown here with these three small cubes, and we'll list it as part, and all of the bodies that make up that multi-body part will then be listed underneath that part. Regardless of the number of bodies here, it always displays this icon of these three cubes, so whether there's 2 or 10 bodies that make up this part, this is a default generic icon for a multi-body part. And the other option is to select the bodies and then go to Tools and Form New Part. But for all intents and purposes, it's easier just to manually select the bodies in the tree and then right click and select Form New Part. So here's some examples of separate parts as opposed to multi-body parts. So in the first case here in DM we have one part and one body consisting of one solid. Okay, so we only have one body here. So the result of transferring the geometry to meshing is that we have just this one body. So this means that the mesh is conformal all the way through. And we can see in the example after we've generated the mesh that because this is all one solid, the mesh continues all the way through. So at the edge positions, you can see on this feature edge, we've got all of the node positions here, which match up between all of these all of these regions and these two particular faces. So it's the mesh is conformal all the way through. But that's because we have one body and we don't have separate bodies. It's not split up into separate bodies. The next example here in DM is 3 parts and 3 bodies. So this block on this side, the main block and the cylinder are all separate parts and also separate bodies. This means that they don't see each other, and effectively they're treated independently. So what happens is when we create a mesh on each of these bodies, this means that the meshes are non-conformal. So there's no sharing of nodes at the interface, and that can be seen on the right-hand image here. Now what meshing will do is once we take this into meshing as 3 separate parts, because there's no sharing of topology here because we're not in a multi-body part, it will automatically find that these two faces are within a contact tolerance of each other and try to create what are called contact regions. And our contact regions will automatically be created when we take it into meshing by virtue of the tolerance of the proximity of the faces. So here we can see we have a contact group that's created and 2 contact regions. So we have a contact region between the large face of the large block and the small face of the smaller block, and also the right hand square face of the large block and the circular face of the end of the cylinder. And these are the two contact regions that were generated. Now, you may actually want a non-conformal to be there to allow, for example, fluid to pass across these regions, or you may not want them to be there for another region, in which case we can delete these contact regions. But this is simply showing the fact that if they're in separate parts, then there won't be any imprinting or sharing of topology, and these meshes will be non-conformal. And the next option is to have one multi-body part and three bodies or solids within the same part. So now, although we have what appear to be three regions here, which are three bodies, that it's actually one part. And this means that once we take it into the meshing, and sharing of topology is automatically invoked when you take it into the meshing, so that there's an imprint operation and we're actually sharing the lower topology intermediate face between the adjacent bodies within the single part. So now, when we perform the meshing, we have sharing of nodes at the interface, as can be shown on the right hand side here. In the contacts region, there are no contacts created because none of the faces are within a proximity of each other to allow contacts to be generated, because it's automatically coincident and sharing of topology. So we don't have any contact regions created. Contacts is listed here, but there are no contact entities listed underneath, which indicate that there would be a contact zone created. So we can see that it's now fully conformal. So I mentioned about sharing of topology, and we can see here the example of sharing of topology for a multi-body part. Essentially, this allows the imprinting of one body onto another body, but this will only be done if the bodies are all within the same multi-body part. So here we can see an example on these two particular bodies. We can see it before sharing of topology and after sharing topology, and we can see here the connectivity on this purple edge, showing that it's actually being used for multiple faces because of the sharing of topology, because that small face is then now shared. It's used not only by the body on the right hand side, but it's also used as a basis for the body on the left hand side. We can also, as an option, perform imprinting as well, and we can see the imprint that's performed after a sharing of topology on the bottom right hand side, of imprinting this body on the right onto the larger body on the left. Imprinting can be useful in order to define name selections. So what we can do is, if we wanted to create this as a boundary zone, as a new region for a name selection, we can perform the shared topology operation and then identify this particular face as a name selection simply by selecting the face, right-clicking, and selecting name selection and defining the name selection so that we can use it in the forthcoming simulation.